Okay, I
Is it
see
share
now.
now?
Yes, go ahead.
Welcome. So good morning, everyone. Today I'm gonna be presenting about confocal laser scanning microscopy. Confocal laser scanning microscopy was found due to the feedback of fluorescence microscopy, another type of microscopy that has shown some bad or some negative feedbacks. Uh, it is actually an optical technique used to visualize microsamples in high optical resolution and contrast. It also allows optical sectioning without the real sectioning for the creation of a 3D image structure, and it was found in 1957 by Marvin Minsky. We have 7 different components, each of an important role, as we can see on the right-hand side for the laser scanning microscopy. And first, mainly, we should have a laser. The laser varies in its wavelengths according to the different applications. We also have a beam splitter. This beam splitter splits between the laser light that is targeted to the sample and between the fluorescence light that is going to be reflected from the sample after the after the laser exposure. We also have a scanner. The scanner allows the motion of the laser light to scan different areas of the sample. We have an objective lens, which determines the optical image and resolution. We have the Z control. This Z control is actually the stage where the sample is going to be put, and it allows the movement of any focal point in a small range. As I remember, it is 1 micrometer. We can move it in a 1 micrometer range. We also has the pinhole. The pinhole is actually the real key behind the 3D sectioning or behind the 3D image construction. Uh, and it as well shows us how much laser light is going to be propagated inside the sample for the depth. And we also has a photomultiplier tube which transforms the light signal that is going to be exposed or which is going to be reflected after the laser light exposure to an electrical signal to be read by the computer. In here, I'm going to show you a small video. It is a 2-minute video which shows the difference between fluorescence and between confocal laser light microscopies. So at first we can see a fluorescence microscope is also an optical way to visualize some small samples. We could see the less number of components that is being shown. We could see any different light which is going to be targeted to the sample, but only one kind of light that is going to be uh, targeted to the sample, which actually here it is a blue light. We could see how it reflected a fluorescence or it emitted a fluorescence light that's going to be visualized by the computer. We could see on the screen how is it actually taken, how is the image taken. Fluorescence microscopy actually shows us the sample as a unit, as a whole unit, without getting into much deeper details, and that's why confocal laser microscopy was invented in 1957. We could see how much complicated is a confocal laser microscopy with having more, with a higher number of components. We could see how it is diverged and then converged, and um, as a result, only one tiny point that is going to be targeted, 1 point of laser light that is actually going to be exposed to the sample. We could see here how the sample is going to be read. At the first, the pinhole actually, we could actually use one pinhole or one depth per time. We could not use, let's say, at x equal 0 and then at x equal 1 in one time. Should at first finish the scanning at x equals 0 for that depth for the surface, and then move into another depth to ease the 3D sectioning. We could see how does it move. and the depth also increases to have a 3D structured image, as we will see now. And here it is a 3D structured that is being shown. So what are the advantages from using a confocal laser microscopy? We could actually see a 3D structured image. We could use it with a low temperature operability. Also, we have some super resolution, which is actually 1 micrometer. It's a bacterial resolution. We could visualize some bacteria. We have a high magnification power, which is actually up to 10,000x. Some disadvantages that scanning speed is really low, and it is actually also limited for the use in dynamic tracking studying. Photo bleaching may also occur from the laser excitation, and we have risk damage after the laser exposure. Here are some examples. It is a real images from a confocal laser microscopy. We could see the filaments of a cancer cell on the left upper corner. We could see cell signaling on the other side from an antibody. We could see on the left down corner a ciliated protozoan. It is a type of eukaryote cell. And we could also see a zebra fish brain in the right down corner. So as a conclusion, confocal laser scanning microscopy is a great technique, great optical technique that opened the door behind some new fields in sciences. The high resolution and also the 3D structuring opportunity facilitated and encouraged its usage in many different applications, not only in medical stuff, but also in some material sciences to check the material, how it is being structured in a 3D way. That's all for the first presentation. Thank you for your listening.
Okay. Rafet, what is the resolution limit for the confocal microscopy? I mean, how small objects can we see by using confocal microscopy? Omar, do you hear me?
Yes, Hisham, I can hear
Did you hear the question?
you. Yes.
Okay. So do you have an answer?
We could visualize bacteria, Hisham. It is up to 1 micrometer.
1 micrometer.
Mhm.
Okay. Does anybody have any questions?